escape from my family. They are doing all sorts of crazy things. There's a Frozen 2 sing along, a Minecraft or Yu-Gi-Oh chat going on, and I've made it down to the basement where I should be safe for a couple of minutes. So I'm going to do a quick video on multiplying binomials. And in order to do that, before I do that, I'm going to start with a quick recap of multiplying terms and things like that. So right here, my area formula is length times width. And I have a length of x squared. I have a width of 2y. So if I multiply them, my area is just, well, I'm going to write it as 2x squared y because it's x squared times 2 times y. Remember, 2y is really 2 times y. So I can move this any way I want. I can write this as x squared 2y. I can write this as 2x squared y. I can write this as 2y x squared. I can write this as y2x squared. Normally we write it as 2x squared y, and the reason why, no pun intended, is because the coefficient 2 tells us how many x squared y's we have. I have 2 y's times an x squared, so I have 2 x squared y's. And then I usually put the x squared before the y because x comes before y in the alphabet. So I'm going to go through real quick. I'm going to do this one. The length is 2y. The width is 3y, which means I get 2y times 3y. Well, 2y times 3y is really 6y squared. So I have 6y squares. And that actually kind of makes sense if you think about it. Check this out. Sometimes I'm amazed at how clever I actually am. This is 2y wide, y, and then this is 3y. And if you use the imagination that these are actually squares, I'd have 1, 2, 3, 4, 5, 6. 6y squared. Well, like I said, these are supposed to be squares. I'm quite clever, not very good at drawing. All right, moving along. Whoa, okay, now I have something a little bit different. I have a binomial. You know this is a binomial because I have x plus 4 and x plus 2. 2 2's. And it's x plus 4 times x plus 2. So what is my area if I had x plus 4 times x plus 2? What would that equal? Now remember, x is just some unknown number. But the reality is, it's the same number in both of these. So I really have, yikes, what on earth just happened? I wonder if I can control Z here. Oh, good, I can. And let's see if I can, I'm going to control Z one more time. I'm going to draw another picture down here. Here's my x plus 4. Here's my x plus 2. And now if I multiply this piece by piece, x times x is going to be x squared. X times 2 is 2x. 4 times x is 4x. 4 times 2 is 8. So when I put all the pieces together to find out what is the area of this box, I get an x squared. I have a 4x and I have a 2x. Because they're like terms, I can combine them. I get plus 6x. That's this pencil fat. I really want that. Plus 6x. And then I still have my plus 8 at the end. Now, I'm going to show you something. I don't really like doing this, but it's called FOIL, and I don't like doing it at all. I'm going to show you, well, before I show you FOIL, I'm going to show you one other thing. You could really just apply the distributive property twice. X times x is x squared. X times 2 is 2x. 4 times x is 4x. And because they're like terms, I line them up. And 4 times 2 is 8. Now when I combine my like terms, I get x squared plus 6x plus 8. Now, a lot of teachers, when they teach this, and I'm not a lot of teachers, I'm just one, they will do something called FOIL. And I understand why people use FOIL, but really, you're just doing the distributive property. Don't make this harder than it has to be. I feel like we're always trying to give things to kids to learn. You already know how to do the distributive property. Don't make this hard. But I will show it to you because I'm sure next year some teacher will show you FOIL and you'll say, oh, Mr. Moore never showed me that. So here we go. FOIL stands for first times the first, which is x squared. Outer times the outer, which is 2x. Inner times the inner, which is 4x. And then last times last, which is 8. And when you combine them, you get x squared plus 6x plus 8. Once again, same answer. I'm going to do one more. What if we had to multiply two binomials? We had something like this. 2x minus 3 and 3x plus 4. Actually, I want to do one more after this. So like I said, you could just do the distributive property. And if you do the distributive property, I'm going to take 2x times 3x. Now I'll write this all out for you. You don't have to. And then I'm going to do 2x times 4. You notice how I put in my plus sign, my addition sign? Plus, and then I do this one, negative 3 times 3x plus negative 3 times 4. And then when I multiply them, I get 2x times 3x, which is 6x squared, plus 8x, plus, and then this becomes a negative 9x, but plus a negative 9 is just minus 9x. And then negative 3 times 4 is negative 12, so plus a negative 12 is just minus 12. Now I can combine like terms, which I have. So I get 6x minus x minus 12. I'm going to do one more example. And check this out. If I had something like 3ax squared plus 2b times 4a minus 3bx. What would this look like? This looks crazy, but once again, just follow it exactly as we've been doing it, and there will be no reason to panic. 3ax squared times 4a. And I'm going to actually do this kind of simultaneous. 3 times 4 is 12. A times a is a squared. Now that's really x squared times 1 because there is no other x, so I'm just going to write down x squared. That's it. That's the first time. Then I do plus 3ax squared times a negative 3bx. Well, 3 times a negative 3 is a negative 9. There's an a here, but there's no a here, so I'm just going to write down my a. There's a b here, but there's no b there, so I'm going to write down my b. And then I have x squared times x, which is x cubed. Plus 2b times 4a. And so I get 2 times 4 is 8. I have a b and I have an a, but nothing else. That's it. Is that frozen I hear up there? It's found me. So now, 2 times a negative 3 is a negative 6. So I'm going to get rid of that addition sign. Negative 6. B times b is b squared. And then x. I have a b squared x. I have an ab. I have an ab x cubed. And I have an a squared x squared. None of them are the same, so I'm not going to combine any of them. This one was way over the limit of what you really probably need to know, so don't worry about it if you didn't get it. If you can do something like this, x minus 2 times x plus 3, wonderful. And once again, I'll do that real quick. X squared plus 3x minus 2x minus 6. I can combine like terms, and I get x squared plus x minus 6. All right, that's it. I hope this video was useful. Enjoy.